Hi there, my name is Scott from the Rocket Stove Institute, currently located in Eugene, Oregon. Now, picture this. What if it were relatively easy for millions of like-minded people to move out of the cities, find community, and still maintain most of the comforts? We're here today to talk about a new and innovative approach to man's basic need of staying warm and having hot water. This work was started approximately 20 years ago by a group of 5 individuals who came together to try and help the poorest of the poor around the world. What they found is that they needed a type of stove for cooking and staying warm that didn't poison and pollute the indoor air and that prevented kids from getting burned. Through this process, they invented a type of stove called the rocket stove, which many of you may have heard of. Rocket stoves are unique in that they cut down on pollution and they increase the heat put out by the fire. Dr. Larry Winiarski, the founder of the rocket stove technology, was known for saying that mankind does not know how to use fire properly. He went on to develop the 10 principles of combustion. Typical fires burn, lots of smoke is generated, and a lot of heat and fuel is wasted. Standard fires don't use the proper air-to-fuel ratio. Using rocket stove technology, we can reduce the amount of fuel used and increase the amount of heat output by a factor of 10. I have personally been apprenticing with John Zielinski, who worked with Dr. Winiarski for the last 12 years up until Dr. Winiarski's unfortunate passing last year. We have a stove that we have demonstrated can provide heat and hot water to an entire eco-village for near zero fuel cost. We can provide hot water, heat for greenhouses, heat for living areas, and even have a hot tub using this inexpensive and easy to build rocket stove thermal battery system. What we want to present to you today is our current state of what we have developed with the hopes of inspiring people to become heat independent and help this technology proliferate. We want to create a network of like-minded people who can take this idea, continue to innovate it, and help expand its potential. So, visit rocketstoveinstitute.org to learn more. Let's get into it. The idea for the rocket stove heating system centralizes around a thermal battery, which is a large insulated tank of water that stores the heated water, effectively storing the heat. Much like a DC electrical battery stores electricity, a thermal battery stores heat. The heat is generated from the rocket stove. Unlike conventional cooking rocket stoves, the rocket stove for this application is created with fire brick and insulated brick. We want to capture and retain as much heat as possible inside the area that is burning. This section, which we call the burn chamber, is the width of a standard fire brick and the height of a standard fire brick set on its edge. It is approximately 6 bricks deep. The mortar that we use to seal the bricks in and then to seal the gaps is a heat-resistant mortar. At the end of the burn chamber, we attach an insulated length of 8-inch ducting. As you can see, there are 3 sections in this model. This is called the heat exchanger. The next step is we have a length of 60-foot copper coil that slides into the top of the heat exchanger. Using a pump, we draw water from the thermal battery up into the copper coil. The water then travels through the heat exchanger and then returns back into the thermal battery at a much higher temperature. Using a 25-gallon per minute pump, we can heat the tank at half capacity, in this case approximately 320 gallons, to 140 degrees in about 2 hours. Now, what do we do with all this heated water? The obvious answer is that we run it to different fixtures that we can use to take advantage of the hot water, such as a shower, a sink for doing dishes, or a hot tub. The part that we are excited to show you is how you can take advantage of this heat to heat enclosed areas, particularly in a greenhouse. For this, what we do is we run a length of pipe from the thermal battery to an area that you want heated. In this case, we have a small icosahedron greenhouse that we use for plant starts. The heated water is pumped from the thermal battery into the base of this radiator. The radiator then fills up with hot water. We then turn this fan on, and the heat from the radiator is forced out into the enclosed area. With this, we can keep the icosahedron heated consistently to around 80 degrees, which allows us to grow in cold temperatures without having to rely on expensive fuel sources. We've not been able to adapt this to a household application yet, but the same idea would apply using a forced air radiant heat setup in a home environment. We have experimented with many different methods of creating the fire, and by no means is this the final answer. Our hope with this video is to give this information out to the world so that you can take the idea and innovate it further. Here's how we start the fire. Currently what we are using is a section of expanded metal, kind of like a grate, that we dip into the same mortar that we use to construct the stove itself. However, it is a more diluted solution, almost like a pancake batter. We dip the grate into the pancake batter and allow it to dry to provide a cement-like coating to prolong the life of the metal grate. We model the burn chamber off of the classic design of the conifer stove. Originally, we had the pellets coming in and falling into the burn chamber using a step method, much like the conifer stove. However, we have implemented the grate in order to regulate the amount of pellets that are entering the burn chamber. We have found that using a higher velocity pump allows for higher temperatures in the burn chamber. Originally, we were using a small 1.2 gallon per minute pump, and we were experiencing burnouts in the sense that the water would boil inside the coil, in which case we would have to extinguish the fire. We found that the higher velocity pump you have, the less likely you will have this issue. We have bricks along the back to hold the grate in place. We still place the grate at a slight angle in order to replicate the pellets falling down in the stair-step fashion. We fill the grate up about halfway with pellets, add some fire starter material to the grate, and then fill up the rest. We typically add a little bit more fire starter to the top and use a torch to ignite the material. As you can see, the vacuum from the chimney pulls the fire forward through the burn chamber in a horizontal fashion. As this continues to heat up, we add more fuel to top off the grate. We place other bricks along the top of the burn chamber to make it as airtight as possible. We then use globs of cement to fill in any cracks that we might experience. As you can see in the back here, the top portion of the burn area is blocked off so that no air comes in, making it so that it is less likely to start to burn up the hopper. As far as the hopper goes, you can really use just about anything, and we've been using another length of ducting pipe. We place it over the top of the grate area where the fuel feeds into the burn chamber, and we simply fill the tube with more material, in this case, wood pellets. Now, what we mean when we say near zero fuel cost, what I'm referring to is that hopefully eventually this will be innovated to use actual wood chips, which are in abundance here in the Pacific Northwest and should be readily available wherever people are at. Contacting arborists or the local county, they should cut you a really good deal on wood chips. However, we are currently just using wood pellets, the standard type that you can buy at the store, in order to just drive the project forward. At this point, we're on autopilot. The material burns, heats up the water that is traveling through the copper pipe in the heat exchanger, and the tank is slowly heating up. The only thing you need to do at this point is to continuously fill the hopper every hour or so. We obviously recommend keeping an eye on the fire until you are used to how the fire behaves and the rate at which the water heats up in the tank. Our hope with this video is to inspire the world to look at rocket stove technology in a different light. We hope that people out there offer ideas and suggestions and any experience that you have using similar systems to heat greenhouses or other homestead applications. Alright everybody, well that's it for now. I hope you got some use out of that, at least got some ideas going. Please visit rocketstoveinstitute.org for more educational materials, including the 10 principles of combustion that we talked about, some scientific documentation about heat traveling through furnace walls. You'll see all the documentation about those conifer stoves that we showed in the video, and also contact information so that you can get a hold of John. John's the head of the Rocket Stove Institute here, so please get a hold of him with any of your questions. If you guys have any ideas, we really want to just give this to you so that you can take it and run with it. We want people to, further innovate this stuff. It's an exciting technology that we're really hoping that you all benefit from. So anyway, that's it. My name's Scott. Y'all have a nice day. Thank you.